G'day guys, this is Frog Licker from Frog Licker Space. Welcome back. Today I'm going to be demonstrating how to import an STL into Fusion360 and then splitting it and building some joinery around that to help it register for a 3D print. Let's get into it. Here we are in the default view of Fusion360. What we need to do is we need to pull that STL into Fusion360 so that we can manipulate it. So we're going to go and insert, and we're going to this insert menu up here on the top. There are a couple ways of doing it. This I found is the easiest way. You can go to File and Open. You can also go to Mesh and insert mesh this way. I'm just going to stay with tried and true right here. Insert mesh. Okay, go here, find my sample. This is sample Nosecone. I actually modeled this here in Fusion360. We'll actually get to see the output of this at the end of this video. When we're inserting the mesh, we're going to have an option to change our unit type. You'll need to set your units for when you're doing your insert. And then what you want to do is grab under this position tab here is hit the center and move to ground. Now, each model is going to be different. You're going to have to play around with this in order to get it the way that you want it. But for this demonstration, that'll work just fine. All right, great. So now we have a model here. It's a big old 3-inch Nosecone ready to go. It is approximately 376 millimeters, and that's not going to fit on even on my printer. I have a Congro T300, and its build capacity on the Z-axis is 350 millimeters. But most people aren't even going to have that. They're going to have somewhere between 200, 250 is going to be their max. So we want to get this thing knocked down based on what most people have. So what I'll do is I'm going to chop this in two at the 200 mark, at 200 millimeters. So let's do that. Well, first of all, we have to get this converted. So the first thing we need to do is, I'm going to show you a cool tool. We're going to, under Inspect, it's Section Analysis. What this will do is it'll allow you to get a cross section of your model. You just select the plane and it'll show you what's going on in here. This is going to be important later on. So we can scroll in here. You see that this is hollow in here. You see the geometry going on the inside. All right. And yeah, that's pretty nice. All right, so let's go ahead and get this thing converted into a solid. So under the mesh menu, we're going to hit prepare and then generate face group. Okay. We're going to select our model. You have the type of fast and accurate for simpler models like this is fine. And then our tolerance are going to be 1/1000th of a millimeter. Hit OK. This will take about 8 seconds. And now we're done. Okay. So now we have all of these vertices here. They're all grouped together. We're going to move this into, or we're going to convert this to a solid. We're going to do that by converting mesh. Hit convert mesh. You can select your model. You have your operation, which is parametric. And then you have two methods. You have faceted and prismatic. Faceted is the old way of doing this. Prismatic is a new function that was added a couple years ago. If you have the paid version of Fusion360, you'll want to use prismatic. It gives you a lot more options when you're manipulating your models. I'll be using the faceted today. Hit that and it's done. You'll notice that this has changed now. It's now a solid body. And over here, I have the solid body icon. I didn't show you this before, but when it comes in as a mesh, it looks something like this. It has this yellow-orange polygon mesh icon, and then when you convert it to a solid, it turns into the silver cylinder. Okay. All right. So now, how are we going to get this thing chopped up? Well, we're going to go in here and we're going to do a construct, and then an offset plane. All right. And now we're going to have to select our reference plane, which is right here on the bottom, and we're going to move it up about 200 millimeters. Well, there's no about. It's going to be exactly 200 millimeters, and there it sits. And so what I'm going to do is I'm going to use this plane as the actual cutting tool. You'll see how that works here in just a second. So we go back over to the solids menu here, and I'm going to set split body. I'm going to select my model, and now it's asking for a splitting tool. Select your splitting tool. So I'm going to actually use that plane. And what it's done is it's opened up this, or it's created this red circle. The red typically means I'm in a cutting mode. I'm going to cut something, and it's using that plane, which has extended beyond the boundaries of the nose cone. It's just going to slice it super thin right through the axis of that. So let's go ahead and do that. All right, now we're done. I'm going to turn off that construction, and you'll see right here that now we have a seam. You can see there's a ring that indicates that there is a face there. So these are now two different parts. So over here we have now two different bodies. I'm going to rename this one. And that makes it a little easier for us to reference. I want to turn off the base. Now I just have the tip of the nose cone and vice versa. Okay, great. And I am going to turn off the base. So now we're going to get into how do I make this printable so that it's going to go together? Well, what we've done so far is exactly what you could do right in the slicer. I can take this model here, export it, put it in my slicer, and I can cut it in half. The problem is I have nothing to register to. So right here, it's all flat. That's how it's going to print. And these are not going to go together very well. So we need a way to positively register these two pieces together like we do in woodworking. In joinery, we use maybe a bridle joint or a half lap or even a dovetail. And we're going to do something similar here. It's super simple. It works great. All right. So I'm going to turn on the tip, turn off the base, and we're going to look at this bottom here. So if I select this here, there's my, there's a face. It's turned blue, which means I can do something to it. So let's go ahead and create a sketch with that. If you didn't see that, finish. You select your plane that you want to manipulate, and then you can click on this create sketch. All right, since now I have one, let me use that one. Edit sketch. All right, great. So what I'm going to do is I'm going to create a flange that extends beyond the bottom of this nose cone, and it's going to socket into the base. So what I'm going to do is I'm going to grab a circle, and I'm going to drag that out here. Now what I want to do is I want to get it maybe just about half or just over half. The closer I drag in, the more resolution I have. So that looks like about half. I think I like that right there. We'll go with that. All right. And now that I'm done, I have my little circle. You'll see here what's going on here in a second. I'm going to finish the sketch. And now I have a ring that, again, is blue. I can do something with, right? Let me reorient this so we can see what's going on here. There we go. And now I'm going to use a tool called extrude. And we're going to create this lip. And I'm going to make that 11 millimeters long. Okay. This is going to use the join operation off of this extrude. So this will become part of the body. It'll be one piece. And if I turn on the base, now what's going on here? Well, if you remember, red means cut, essentially. And if you look right in here, it's cutting out a section that exactly matches that flange that we just extruded. I'm over here in cut mode now. It automatically switched to cut mode from join because it recognizes that there's interference between these two parts. So I'm going to go ahead and do that. I'm going to hit OK. Now you can see that it has recessed out this area in here. All right. So let's go ahead and get that flange going again. Now, if I leave this base body right here like this, it will join the three of them with this added area. We don't want that. So let me go ahead and turn this off. And then we'll go back up here, get my sketch turned back on, select my ring, hit extrude, and go to 11. And now I'm good to go. However, with 3D printers, tolerance when you're mating parts together can always be a little sketchy. They're not going to be spot on. For my printer in particular, I know that the tolerance is 0.3 millimeters. So what I would do is I'm going to take this and back it off to 10.7, and you'll see here in a minute what there's two benefits for that. Okay, so we'll do that. All right, let's turn the base back on. All right, so now it's a nearly perfect fit. I mean, it's spot on, and I've actually printed this part before, and it actually is a really nice fit because there's no tolerance on these two, between these two. They kind of tend to bow out a little bit. So it's a good friction fit when I'm putting this part together. The thing is there's a tiny little gap in here, right? There's two things for this. First of all, that gap allows us to get a really good connection between these two pieces at the seam. Not only are we looking for mechanical strength here, but we also want it to look nice. This is our seam right here where that ring is at. And we want that to be as tight as possible. So if you're gluing this up with epoxy, you're gonna put epoxy in there, and there's gonna be a little bit of squeeze out. You can run your finger around it and get that gap filled in pretty good, sand it down really nice. You'll never know that it was there. But if you have a tolerance issue and you put your flange down to 11 and it's hitting this lip, this top piece, the tip of the nose cone, could stand a little proud, and you're going to have to do a little bit more work, or it could cause you a lot more post-processing, and we don't want to do that. Second of all, it also gives you a bit of a gap in here for epoxy to sit in, give you a little extra surface area. It's not a lot. It's not going to change the world or anything, but, belt and suspenders. All right. So now we have this split up. We're ready to go ahead and export this. So let's go ahead and do that. Export. Let's put it in to downloads. We'll call this sample Nosecone. All right. We're going to want to set this down here to STL. All right. Nope. I'll call this. Frog liquor sample. All right. All right, now it has been exported. We're going to open up Orca Slicer. And we'll go ahead and get that imported. Project. I am going to, I don't need an extra one of these. Okay, frog liquor sample. All right, now this came in and it looks exactly like the sample nose cone that we started off with. Now, what we need to do is select it and hit the split the objects because they're loosely coupled inside of the STL. All right. And let's go ahead and we'll arrange these. And now you can see that they are ready. This is exactly 200 millimeters. So you could print this on most printers. So as I promised you, I wanted to take a moment to just show you the end result. This is that nose cone that we just converted and split. And up here you can see that lip, the recessed area that we created. I have supported the shoulders here to give a nice crisp edge there. And then here's that nose cone. And then this is the nose cone assembled. And it looks really good. The seam is barely perceptible right in here. You could take some Bondo spot putty, and after the epoxy has cured on this, you can run just a tiny little bit, just right over the edge, just to fill in that gap. Let it dry, and then sand it down. Bondo spot putty sands really well, and then just give the whole thing a sanding. You just run through the grits, and once you get it down to that point, you throw some more primer on this thing. It's just going to look like a really nice, high quality nose cone. It's going to be really solid, really strong, and I think you'll be very happy with it. All right, if anybody has any questions, feel free to reach out to me on the Rocketry forum. My handle is FrogLicker, or you can leave a comment down below on this video. Thank you so much for watching, and have a great day.